All right. So at Netflix, we invest in technologies that bring great stories to life. And we constantly innovate to bring a high quality and seamless experience to our users. That could be new encoding recipes, new adaptive streaming algorithms, content delivery networks, and our unique blend of entertainment and technology means that we have some other opportunities that we'd like to explore around new ways of telling stories. We've done a pretty good job of convincing users to chill while they watch their favorite stories. So step 0 in this whole experiment was actually to get them to pick up their remote and engage with the content, actually participate. And to that end, each of our interactive originals to date have come along with a little tutorial that's branded as with the content and encourages the user to interact with the story. So I thought I'd share the one that I like most from Bandersnatch. Oops, if this will work.
This is an interactive film where you make choices which alter the story. Throughout your viewing, there will be moments where choices will be presented at the bottom of the screen. Use the left and right buttons on your remote to highlight your selection, then press OK. Keep your remote in hand. Do you understand? Use the left and right buttons on your remote to highlight your selection, then press OK.
Nobody has a remote? Okay. So,
once again, you'll need to use your remote to choose yes or no.
We're in a dystopian future. Okay. So, seamlessness is a common theme that you'll hear throughout this presentation. And in that tutorial, I wanted to point out the interaction between the UI and the video itself. So that represented a choice point, which is something that we'll dig into a little bit further down the road. But first, I wanted to mention that this whole endeavor really required a lot of collaboration across the entire engineering organization at Netflix, from post-production to ops to encoding, which is where I sit, to the UI and streaming client technologies teams. It's really their work that I get to present today, and so I want to call that out. Tight collaboration was also required with the creative themselves. This is Charlie Brooker, who's the creator of Black Mirror, demoing some tech at Netflix headquarters. Because the UI was such a critical part of this experience, they actually wanted and needed to be able to see what that experience would look like to the user before they even went out and shot something. You can imagine that the experience with the UI could make your choices around the way a piece of dialogue is presented or the timing of a scene. Those could have a really big impact. So this seamless experience is really important. This will be our default path for the next 20 minutes, assuming we don't hit any weird nonlinearity bugs or interruptions in our current space-time continuum. And we'll go through a very brief primer on adaptive streaming, the anatomy of a branching narrative in general, Black Mirror, Bandersnatch in particular, and then work backwards to our source delivery model, which I thought might be more interesting to the folks in this room. I would be remiss if I didn't mention that all of this has to be done at scale. So a proof of concept is one thing. You can get it running on one device or it works in your test environment. But for us, we're talking about 10 years of installed device base around the world of different abilities and capabilities like HDR, Dolby Vision, all those guys. So this was a really big we leaned on a lot of the scale that we had achieved previously in terms of encoding and streaming to make this work. The streaming client guys worked really hard to make even the playback experience seamless so that you didn't feel like you were jumping around inside of a bit stream when you made a selection. So simply put, buffering is the enemy. Okay, so my job at Netflix, I like to say, is to throw away data. It's kind of ironic in a conference like this where we all talk about preservation, but at the end of the day, not everybody is connected to Google Fiber, and so we have varying network capabilities in our users' homes. So we'll go a little bit into a little bit about how adaptive streaming works. So here I've constructed a scenario where we have a 400, 1800, and 2700 representations of the same content. And you can see that it's broken up into these little chunks. These are all the same length. And if we have a network throughput that looks something like this, then an adaptive streaming algorithm might come up with a solution like this to make sure that you're never starving the player for bits. That's really what causes a rebuffer, is that your decoder just wants to play back at real time, and you just can't manage to get that data into the buffer fast enough. In the case of linear playback, the problem is a little bit simpler. The player doesn't have to worry too much about the next frame that it's playing. It's just the next frame. It's not coming from anywhere else in the file. It's all contiguous. Obviously, that breaks down when we start talking about interactivity and letting users choose new branches. Okay, so let me talk a little bit about interactive. I know that's probably a review for a lot of you. In 2017, we launched our first interactive original, Puss in Book. That followed with a few other children's titles, and then at the end of last year, we launched Bandersnatch. With what we were really trying to do here is build a framework for storytellers to utilize technology on our platform and feel comfortable in that process, supporting them. And with each title, we had new challenges. There were new requirements. And this slide is meant to sort of demonstrate that by taking each of these titles and putting it into a graph. So this is Puss in Book, where you can see that each node in this graph is a segment where you're playing linearly, but then you're giving the user an ability to jump around. This is Minecraft Story Mode. And then, of course, Bandersnatch looks like this. This is the actual graph from the choice map generated for Bandersnatch. We removed the text to avoid any spoilers, sorry. But, so, what would you do? You're a room full of engineers. If you're given a challenge like this, how many people have watched Bandersnatch? Oh, great. Oh, good. Then these jokes will land. Okay. What happened at Netflix is we developed a tool called the Branch Manager. Internally, we refer to these titles as branching narratives, and I'll use that term interchangeably. The Branch Manager really is the tool that allows Charlie Brooker to get that spaghetti mess into a tool, into a format that we can consume on the streaming side. And so this was a tool that was given to them during their production phase to try to manage a lot of this complexity. And they must have liked it because it actually gets a cameo in the film. I don't know if you've seen Bandersnatch. It's possible that you've seen this timeline, and it's possible that you've seen Branch Manager in the movie. Okay, so I mentioned some of these terms already, but each of these titles is constructed as a series of interactive segments. These segments are laid end-to-end in a single timeline. A choice point may occur at the end of any given segment where the user is given a small amount of time to make a choice. The choice is locked in, and then at that point, either a new segment begins or some state is set in your session. This basically means that a choice that you make early on can affect a story later, your story down the road, and otherwise you wouldn't really notice. Playback across segments is seamless, and we decided early on that loops would be okay. Bandersnatch launched in December last year. This is an interactive film by the creators of Black Mirror. It's set in 1984, and this is Stefan, the main character. He's developing a video game with some very similar properties as the film itself. And some of the features that were developed to make this a really seamless experience were the Branch Manager, the UI, which we saw an example of in the tutorial, and we'll dig in just a moment. The seamless playback was very important as well, and a lot of work was done on the streaming client side. I'll just discuss one piece, which was separating the download from playback. And then arbitrary keyframe insertion on the back end, which is on the encoding team where we were involved. And this was essentially to adapt our long-running contract between the encoding back end and the streaming clients, which was that we would always have a random access point, a keyframe in the bit stream for them at every 2-second interval. So at any 2-second interval in the file, you can jump from one bit rate to another and be guaranteed that you won't have any dependencies on a previous frame. So let's dig in on a choice point. This is the graph view on the left. So this is Stefan getting offered a job at this new video game company. There are 2 options, accept and refuse. And depending on, we'll go through the choice point itself. So the life cycle of the choice point has 4 phases. So firstly, we've got this initialization where the black shows up at the bottom, the timer is started, and your timeout, your choice is locked in, and then the UI goes away. So this is, we can map this to some media. So this is a segment of media where you can imagine that at the beginning they're saying, hey, Stefan, don't you really want to work here? And then encouraging the user to get to engage. We've got the initialization. This is all while the video underneath is running. And I put a little JSON blob up there to show that this is actually a configurable experience. So if in Branch Manager, if you decided that you wanted more or less time for a specific choice point, you can actually provide those values to the client. So what happens after you've made your choice? Well, now the player needs to get the frames from whatever segment is supposed to be played next. I mentioned that in linear playback, that's not such a big deal because there's a lot of work to make that go well, but you always know what the next frame is going to be because it's logically the next frame in the media file. If you accept the job offer, for example, that's still true. You can just pull the next contiguous frame, but as you see, the refuse branch is actually way down the bit stream. So in this case, there's a very tight, there's a very limited amount of time between when you know which branch is supposed to be played and then the actual getting those samples down to the decoder buffer. And so the solution here, or one solution, would be to separate download from playback. So as you're watching the job offer segment, you're actually downloading both branches in the background. And it's not until you've made your selection at the very end of that job offer segment that we start appending the right media samples into the media source buffer. Okay, and it would not be a Netflix presentation at a SMPTE or HPA event if I didn't talk about IMF. So this is a little walkthrough of how we iterated on our delivery model. This is the giant chicken from Minecraft Story Mode. This was an analogy that I wanted to make between, so there was a choice at the very beginning of Minecraft Story Mode where you answer a hypothetical question, whether you'd rather fight 100 chicken-sized zombies or 10 zombie-sized chickens. And I don't know about the room, but the chicken-sized zombies is my choice just because it seems more scalable. But the fact of the matter is, this was still a very early push, especially. We had to come up with these delivery specs very early on. It was before any of this was proven out that anybody would even care about interactive content on our platform. So we ended up going with the zombie-sized chickens. And by that, I mean that we still had this requirement in our encoding pipeline to place keyframes at every 2-second boundary. And it was actually going to be quite a bit of work to go in and change that model because everything kind of relies on it. So instead of doing all the engineering work up front, we kind of pushed this complexity upstream. So this is the delivery spec that a fulfillment partner would have to meet to deliver an interactive title to us, which basically meant that all those segments that were laid out on a timeline had to be on 2-second boundaries. And that way, when it showed up into our system, it would magically get a keyframe at each one of those segment starts. So this is just that old graphic with new content. So we've got the pink, which are the segments, and then you've padded the black and silence in there to make sure that everything hits the right place. We also iterated on this XML schema, which defines, you can see each segment, where it begins and ends in that master timeline. This was a very tight coupling between the metadata needed to know how all of the segments interact with one another, and the IMF itself, which had all that media laid out, which meant that it was tedious to build the IMF in the first place, but then if you wanted to change something down the road, it was even worse. Because if your timing changed in any way, then you'd have to update the XML and redeliver. So this giant chicken model basically showed that it was unscalable with episode 4 of Minecraft Story Mode, which arrived in our system as a 19-hour IMF file. Luckily, we have a very robust and scalable distributed encoding pipeline. It broke a few of our analysis tools, but that was okay, and it freaked out all the infrastructure teams. But the encoding worked out pretty well, and we were able to deploy it eventually out to CDN. One of the reasons that this is such a long file, I just wanted to mention this Minecraft Story Mode. The first choice you make is whether you're going to play as a male character or a female character. So in this model, that basically means that at the very beginning, before you've done anything else, you've doubled the length of the experience that any one user is gonna have. So we iterated on the source delivery model with an annotated IMF. So in this case, it was a little more elegant. You could lay those segments out end to end. You didn't have to do any padding. You just had to include a marker track that included the FPCI marker. And in the annotation of that marker, you give us the segment ID, and then this CSV file is where all the logic lives about which segments can interact with others. And that was just an easy format for people to spit out of a spreadsheet or whatever. So worked out pretty well. We added support in time for Bandersnatch to get these arbitrary segment boundaries. So anywhere the marker track instructed us to start a segment, we placed a keyframe. And this is sort of our goal for 2019 is to get toward some segment-based delivery model. This is still in progress, but the idea here is that if we are going to scale this project, we'll need to do something about those giant files. So in this case, basically you could deliver a series of CPLs or something along those lines, each for a different segment, and then it allows us to decouple the source encoding model from the client implementation model in a nice way. We could produce a new CPL, for example, that strung segments together in different configurations so that we could look for different optimizations. And then the question is there interest in the room? Is there prior art? Is there some way to align on best practices in this case? Are other people going to be producing this stuff? So I'm open to those discussions, and that's my presentation. Thank you. Any questions?
Hi, Rick Ackermans, MVA Broadcast Consulting. With Netflix being available on probably more platforms than everything else, everything from Roku's to Blu-ray players and probably some kitchen appliances. How does the playback work with such a wide variety of platforms having access to Netflix?
Yeah. So as I mentioned early on, we have that huge installed device base. And so some devices just are too old for the challenge, but we tried in a big way to keep a unified experience across the whole product. And so the answer is just that there were, in many cases, device-specific implementations done by those teams on the client side. So the web browser is one that I kind of used as an example in mind, but they could be wildly different on other platforms.
Yeah, not a question, but an answer, yes.
Okay,
Speaking as
interest,
president
yeah.
of SMPTE, since I see Thomas nor Bruce are here, absolutely, we should see what work we could do to make
Great,
this work
yeah.
better.
Happy to have lots of conversations.
Yeah, Netflix always collects a lot of data. So are you collecting a data on every click?
Collecting data on every tech?
On every selection?
Oh, so your choices are recorded so that, we know. So there's logic in the player that needs to know what your previous choice was because it sets some state in the UI to give you a different experience based on your selections. So there's actually one slide that I took out because I thought I would run out of time, but it shows, it kind of alludes to the fact that even though there are two options in the in that job offer choice point, there's only accept and refuse. There are actually 4 different outcomes. So, but in terms of like user data, I don't know where it's stored or for how long after the session is ended. So.
Another question here. Hi, Michael Klein. How well is interactive storytelling being accepted by the viewers? Because I guess I'm old school and I want to sit back and watch TV. I don't want to have to click every 5 minutes.
Yeah. So we've actually seen really good engagement. That was a big reason that Bandersnatch happened. It was that the kids' content, and I think there was a play there that thought, the kids might be more likely to sort of picked up the remote and interact like a game. And we saw really good engagement there, and so that's when we decided that we would try something out for the adults. Have you watched Bandersnatch? It works really well, Bandersnatch, because the story is so kind of self-referential to the medium. I recommend that you give it a shot, but we have seen really good engagement, and I would expect to see more over time.
Anthony Magliogo. A couple of questions for you. You have the programmer controlling the user response time. Can you let the user control the response time if they're handicapped? And then, of course, probably has a support for resume when you leave the show and want to come back.
Yeah.
Have you considered any voice control? Because, of course, the Roku does have a voice input. I noticed that most applications don't support the Roku voice. It's kind of sad.
Yeah, those are all great questions, and they would be better directed to our UI engineering teams, but I think those are all really interesting recommendations, yeah.
And is there any carryover from the old days of LucasArts, like Manny Calavera and the Grim Fandango series, where you actually were very interactive? You can go back anywhere in the path. Sounds like you're doing that.
So I'm interested to learn more about some of that stuff just to see how it was modeled out and how the data was recorded. My guess is that a lot of that was just like custom built for a single project or whatever, but if there were any like sort of practices that people really appreciated, I would love to see that stuff just because. Okay, yeah, well, I'd love to learn more, so.
Do you provide any feedback to the story creators as to what segments were popular or never chosen, et cetera?
Yeah, in fact, I think some of that data has even been, there's some data that's been shared even publicly. I think if you go back and find the investors call that Reed Hastings always participates in, he actually talks about like how many people chose Frosties over, there's a choice where you had to pick what cereal you're gonna eat in the morning, and he talks about how many people chose Sugar Puffs over Frosties or something along those lines. But yeah, the creators are always very involved in these, and we do think that giving that information back to them really helps them kind of refine a process for the next project.
And I'm afraid that has to be the last word.
Thank you very much.
Thank you very much, Andy. Jay-Z, come on up.